Hello, this is Mr. Hanna, and welcome to What the Format. Today we're going to go over the transformed exponential function. Now, hopefully you saw this is a series of videos. Again, not one video doesn't cover the whole subject. You'll need to watch and compare, make notes. Try to make a list of what you're struggling with. Go back to the videos. Try it again. It may take some time, but eventually things will start to click. When they do, this will become a lot easier because you'll notice I'm doing the exact same thing to the exponential function that I did to the others. Look, there's my base function. Oh, I forgot to do one thing, didn't I? I forgot to do what? Okay, I don't want that to be like my function, so I'm going to dash it. That tells me that's my starting function. Okay, so there's your parent function or base function of the 2 to the x. Okay, remember I did the points in another video. Compare that, see if I got them right. Okay, 2 to the 1 is 2. Right there, 2 to the 0 is 1. 2 squared is 4. 2 to the negative 1 is a half. There's your quarter. Of course, a half and a quarter are a little bit harder to graph, but you get the general idea. Now, I didn't cover this yet, but in another video when we go over exponentials, I just did 2 to the x. There's a lot more bases. So when we actually get into the other bases, there'll be another video that takes exponential functions into more detail. But for now, we're going to keep it like this so you have a nice comparison. And 2 to the x is the easiest exponential function to do, so that's what we're doing. Okay? I will address this behavior in another video. It's called asymptotic behavior or an asymptote. Okay? A-S-Y-M-P-T-O-T-E. Asymptote. Okay? But like I said, we can't do everything all at once. That's behavior for another day. Okay? For now, you just need to kind of draw a line that approaches that. Right? Now, there's my function. So once again, it's going to transform the same as the others. It's going to move left 1. It's going to go down 3. It's going to reflect. So it's going to go down, and it's going to stretch. So it's going to get maybe a little steeper or skinnier than this shape right here. How? Well, let's look. So negative 1. Again, we're going to plug that in. Okay. What's 1 plus 1? Oh, I forgot the sign. See how I checked myself? Negative 1 plus 1. Always check that. Okay? Easy to make a mistake. See how that works? So, now I have negative 2 times. Negative 1 plus 1 is 0. What's 2 to the 0? Remember, anything to the 0 power is 1. So now that's negative 2 minus 3, which is negative 5. And yes, you'll notice that that's different than the other two functions. The others started at negative 1, negative 3. This is starting at negative 1, negative 5. That's why you want to get in the habit of doing the math. Don't make assumptions. Okay? Now, what do we want to plug in negative 2? In the last ones, I plugged in negative 2 and negative 3, and notice I was dealing with negative numbers. I can do that. So can you, but negatives get to be tricky. Did you know the number one missed thing in all of math is sign changes? So if they're that tricky sometimes, or the number one missed thing, why tempt fate? Why do that? We could have picked either point here, right? Now, that was for the last two functions. Maybe you'll remember in one of the videos I said you have to do all 5. So in this case, we can't just pick 2 and be done. We have to do all of them. But maybe it's easier to start with the positives than the negatives. Maybe that helps me feel more comfortable about the problem. Whose decision is that? Yours. If you want to do the negatives first, get those out of the way, do those first. Okay? So I'm going to go with 0 plus 1. I'm going to go to the 0. What's 0 plus 1? Well, instead of 2 to the 0, now I have 2 to the 1. And 2 to the 1 isn't 1, it's what? 2. Recall, that's an exponent rule. Any base raised to the power of 1 is itself. So 3 to the 1 is 3. 4 to the 1 is 4. A million to the 1 is a million. Okay? That's a math fact. You're going to want to remember that. So negative 2 times 2 is now negative 4. Yes? And then negative 4 minus 3 is negative 7. Notice how the math changes. But that's all. The steps themselves. Parentheses first. Exponents. Multiplication. Then your addition, subtraction. So this is multiplication, then my subtraction. That's the forward order of operations. Remember, we're evaluating forward PEMDAS. See how it all comes together? So if you're having trouble with forward PEMDAS, go back and practice it. Okay, that's negative 7. So now when we plug a 1 in there, what do you think we get? Well, 1 plus 1 is now what? 2. What's 2 squared? Well, that becomes 4 down here. See that? And negative 2 times 4 is negative 8. Minus 3 is negative 11. Now, like I said, we can't mirror these points on this function. Well, how do I know that, Mr. Hanna? Well, when you're studying functions, you need to know what characteristics they have. Some functions mirror. They have an axis of symmetry. Others do not. Both the absolute value function and the square root, or not square root, sorry, the square or quadratic function have axes of symmetry, so they mirror, so you have to do half the work. Here, you're going to have to plug those in, okay? But if you're getting good at this, you'll notice I'm only replacing one number each time, so it changes the power, which changes that number, which changes that, which changes this, yes? Okay? So now I have what? Negative 2 plus 1, which is negative 1. 2 to the negative 1 is 1/2, okay? A negative power simply reciprocates you. So 2 over 1 becomes 1/2. Once you've reciprocated, the negative goes away. 1/2 to the 1 is 1/2. Okay, now that's the video I'm probably going to have to do later on exponent rules, and you're going to have to watch it if you're having trouble with this. Okay, but for now, you need to remember that 2 to the negative 1 is 1/2. Negative 2 times 1/2 is simply negative 1. Negative 1 minus 3 is negative 4. Dodged a bullet there. That could have been a fraction, couldn't it? But fortunately, this 2 canceled the fraction. Might not be so lucky on the next one. So we go negative 3. Negative 3 plus 1 is negative 2. That's going to be 1 over 2 squared. So if I write that out, 2 to the negative 1 was 1 over 2 to the 1. So 2 to the negative 2 is 1 over 2 squared, like that. That's what negative powers do. Well, 2 squared is 4. So that's just 1 over 4. And yet, we're not so lucky. Now we have a fraction. Negative 1/2 minus 3. Now, I don't recommend that you do this as a mixed number, but you could. So a negative 3 1/2. I'm going to write it as negative 7/2. Okay? That's going to be the best way to look at it, but it is negative 3 1/2. So now when we graph it, what do we have? 0, 1, 2, 3, 4, 5, 6, 7. Yes? Negative 1 is at negative 5. 1, 2, 3, 4, 5. See that? Okay? Where is negative 2? It's at negative 4. Yes? And this is at 3 1/2. Yes? You'll notice that this becomes my asymptote. And that would make sense because if the asymptote was at 0, minus 3 is going to move your asymptote down as well. Okay? Then this is going to be at 1, negative 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's down here. And you'll see that there's your shape hooking down like that. A little harder to see the stretch on that one, but it did stretch. It did get a little skinnier. And there you go. Now hopefully you're seeing that I follow the exact same process regardless of the function. And in Algebra 1, these days, these are the 3 functions that they're pushing. Okay? I don't necessarily agree with that order, but when I look at different curriculums, that's what they want you to know. Linear, quadratic, and exponential. I think you should know the absolute value too, so I threw that in there. Also, absolute value, it's easier to see the transformation, so now you have 3 functions to compare instead of just 2, so you can start to see that there's a pattern to it. Because sometimes when you look at 2 things, they have a connection, but that connection doesn't always go to other things. In this case, you'll see that the transformations are all the same. Left 1, down 3. It reflected over the x-axis, and then it stretched. I'm doing the stretch down because of the reflection. And it was the same, and my process, my x values were the same because the x plus 1 was the same. Okay, so finding that center point is very important. The center point, 0 point, vertex, depending on some functions have what's called a vertex, some don't, but they all have a center point or 0 point. And that's where what's being done to the x is equal to 0. Remember I set x plus 1 equal to 0. We could do it again just to reinforce that. The x plus 1 equals 0. When I subtract 1, I get x equals negative 1. That's why I started here. Then I went up 1, down 1, down 1. Same thing I did with the others. So if you watch all 3 videos, hopefully that's the first thing you see. Once you start to get your process down, what you do it to doesn't matter. Once I figured that out, upper level math's been easier for me because I learned that every function has a couple characteristics. Once I get those down, the other stuff isn't new. I've been doing it the whole time. Hopefully you see that. Hopefully this is starting to make more sense. We'll cover more things in more videos later, but hopefully that's a good start for you on my channel. Looking at my videos I made before and now these new ones, hopefully you start to see math facts to math skills to math problems. You can't do math problems unless you have your facts and skills down. If you're not having your facts and skills down, pause, go back and start to pick those up. Okay? It'll make your life a lot easier. Otherwise you'll stay lost forever and math won't be very fun. Anyway, hopefully this has been very helpful. Thank you for watching What the Format. This is Mr. Hanna. Happy mathing.